The Constitution of India, Preamble. We, the people of India, having solemnly resolved to constitute India into a sovereign, socialist, secular, democratic republic and to secure to all its citizens justice, social, economic and political, liberty of thought, expression, belief, faith and worship, equality of status and of opportunity, and to promote among them all fraternity, assuring the dignity of the individual and the unity and integrity of the nation. In our Constituent Assembly, this 26th day of November 1949, do hereby adopt, enact and give to ourselves this Constitution.
So welcome back, children. Last week we were peeping into the history of classification of elements, and we discussed about the earlier attempts of classification of elements, isn't it? The first scientist to make this attempt of classification of elements was Lavoisier. What did Lavoisier do? He classified elements into then existing elements, that is 30 elements, into metals and non-metals. But the limitation was he was not able to classify or categorize some elements into both the categories because they exhibited the properties of both metals as well as non-metals. The second classification was done by Dobrynin. What did Dobrynin do? Dobrynin classified the then existing elements into triads. What are triads? Triads are a group of 3 elements. Okay? So, he also said that when you add the atomic mass of the first and the third element and find out the average, you will get the atomic mass of the second element. Here also there was a limitation. The limitation was Dobrynin was not able to categorize some elements into these triads. So, the third classification was done by Newlands. What did Newlands do? Newlands classified the then existing elements into a table which he called as octaves. So, when he arranged elements into octaves, the first and the 8th element exhibited same physical and chemical properties. So, in short, the elements coming under the same group showed similar physical and chemical properties. Here also the limitation was he was not able to classify elements with higher atomic mass, into such octaves, into these octaves. The limitation was Lavoisier was not able to categorize elements with higher atomic mass into these octaves. He was not able to include these elements in these octaves because they did not show similar properties. Okay? Now, the fourth classification we discussed in our previous class, and it was done by Mendeleev, Dmitry Ivanovich Mendeleev, who was a Russian scientist. Mendeleev attempted to formulate all the then existing 63 elements in a table. So, he was the first person to formulate a periodic table. So, he is called as father of periodic table. So, what are the important points to be noted in Mendeleev's periodic table? Yes, they were categorized as merits and demerits. What were the merits? Before that, in Mendeleev's periodic table, elements are arranged in the increasing order of their atomic masses. That was point number 1. Point number 2, yes, he formulated the Mendeleev's periodic law, which says that when we arrange elements according to the increasing order of their atomic masses, the elements coming under the same group exhibit similar physical and chemical properties. There were 8 groups and 8 groups and 6 periods. Okay. So, these are the important points to be noted in Mendeleev's periodic table. Now, we also discussed the merits and demerits of Mendeleev's periodic table. What were the merits? Yes, what were the merits? The first merit was, since elements were arranged in the increasing order of atomic mass, the study of elements in chemistry became easier, isn't it? So, the study of elements became little bit easier. And the second important merit in Mendeleev's periodic table is, he redetermined the atomic masses of some elements which were wrongly determined. One such example was beryllium. He changed the atomic number of beryllium from 14 to 9. So, this is wrong, 14 is wrong. He changed it, correctly determined it to 9. And the third important merit was, he left some vacant spaces, empty spaces. Mendeleev left some empty spaces in his periodic table for the future discovery of elements. So, he gave a space even for the future scientists. Those were the merits of Mendeleev's periodic table. What were the demerits? The first demerit was, hard metals like copper, silver, gold, these were all grouped along with soft metals like sodium, potassium, lithium. Okay? So, that was a wrong grouping. So, Cu, Ag, Au, it specifies Cu is copper, this is silver, Ag is silver and Au is gold. So, copper, silver and gold were grouped along with the sodium, potassium, lithium. These are all soft metals, whereas these metals are, as you know, they are quite hard metals. So, that wrong grouping was done. And the second demerit was, hydrogen is not given a proper place in Mendeleev's periodic table. As if you see, hydrogen is placed above metals. Hydrogen is not a metal, so why is it placed above metals in the same group of metals? So, hydrogen is given a wrong position. And the third demerit was, yes, Mendeleev said that elements are arranged in the increasing order of their atomic mass, but this was not properly followed in the case of cobalt and nickel, tellurium and iodine. So, you can see the atomic masses were a bit varying in these two cases. The arrangement of these elements were a bit varying in Mendeleev's periodic table. So, these were the merits and demerits which we see in Mendeleev's periodic table. So, these are the things we studied in previous two classes. Now, we are going to move into the modern periodic table which you are following right now. Who discovered it and what are the changes in modern periodic table? We will see to that. In 1869, when Mendeleev formulated his periodic table, the structure of atom was not so deeply studied. Okay? Today, we are into the fourth chapter. Actually, periodic table is the fourth chapter, isn't it? So, last week I have wrongly said it as third chapter. So, periodic table is our fourth chapter. So, what was our first chapter? It was about the structure of atom. So, now we are completely studied about the structure of atom. But when Mendeleev formulated his periodic table, structure of atom was not studied so deeply. By the time Henry Moseley formulated the new periodic table, that is the modern periodic table which we are following right now. So, by the time he formulated the modern periodic table, the structure of atom was deeply studied. more deeply studied. More and more researches were done on the structure of atom. So he had a clear idea of all the elements, then existing elements. Mostly modified the Mendeleev's periodic table into the modern periodic table. A slight modifications were done in his periodic table, and here we have the modern periodic table which has all the 118 elements. So what are the important features of modern periodic table? The first one was, how did Mendeleev arrange the periodic table? He arranged according to the increasing order of their atomic masses. But by the time the study of structure is over now. So now mostly arranged all the elements according to the increasing order of their atomic number. So that was the most important feature in modern periodic table. So in modern periodic table, elements were arranged according to the increasing order of their atomic number. Now based on that, he formulated the modern periodic law. What does modern periodic law say? The chemical and physical properties of elements are periodic functions of their atomic numbers. So what does this mean? It means that when elements are arranged in the increasing order of the atomic numbers, the elements coming under same groups will exhibit similar chemical and physical properties. That was the first important feature of modern periodic table. What else? The total number of periods in modern periodic table is 7. How many periods were there in Mendeleev's periodic table? 6. Children, now shall we have a look into the modern periodic table? Yes, this is modern periodic table. As you see, how many periods are there? What are periods? The horizontal rows are periods. So 1, 2, 3, 4, 5, 6, 7 periods are there, and the last 2 periods will be the continuation of 6th and 7th period. Okay? We will discuss that later. What else? Which is the shortest period now? Yes, the first period is the shortest period. You have only 2 elements, that is hydrogen and helium. These are the 2 elements in the first period. How many elements are there in the third period? You can count. Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine and argon. So 8 elements are there in the third period. So how many groups are there? As you can see, 18 groups are there in the modern periodic table. So these are the important features of modern periodic table which was formulated by Henry Moseley. So shall we discuss once more what are the important points? The first point is that elements were arranged in the increasing order of their atomic number. There are 7 periods and groups, 18 groups are there in modern periodic table. So how many groups are there? 18 groups. So if you see roughly, the first period is the shortest period. Only hydrogen and helium is there. Hydrogen and helium are there in the first period. We saw one more example, that is third period. We saw third period has got 8 elements. So these are the important features of modern periodic table which was formulated by Henry Moseley. So children, we will go deep into this modern periodic table in the coming classes. This week we don't have any assignments as you will be facing some more exams, isn't it? So I hope you have done all the exams by now. Some exams are over. I hope all of you have done well, and all the best for the forthcoming exams too. Bye. We'll meet in the next video session.